Okay, share screen. Hey, join video. Sorry, I mean all. Okay, good. Let's continue. Okay. So this one is you generate from a normal picture. This one, I just need one line of code. 255 minus that. What is that? 255 is the maximum color. So the number is lower, you got more dark. The number is more high, you got more bright. So 255 is the full scale. So in order to invert the intensity, you just get the maximum value to subtract the original value. So you just need one line of code, 255 minus the cat picture, and actually do the broadcasting. This 255 minus every single color, and you just have this in one line of code. Okay, the other lines of code is just displaying the pictures. Okay, so all you need to do is the cat picture you read in from a file, and this 255 minus that. Okay, you can actually think of that. Oh, how about using all those slicing and so on? Then you actually make a bigger picture, smaller picture, scaling picture, make it brightens, whatever. It's actually convenient for that. Okay, conceptually a lot more convenient than other language. Yeah. Because your picture may not be square, right? Yeah, can be a rectangular long pictures. So your width and height actually. Yeah. Yeah. So the width and height, the height is actually the number of columns, right? No, sorry. The height is actually the number of rows. Height is number of rows. Is it okay? Height of the picture is the number of horizontal rows. Width of the picture is number of vertical columns. Okay, so it's n times m. So actually n times m, I will assume n is the row numbers and m is the column number. Okay. Yeah. Okay. For example, we can actually do a lot of data slide analysis like that. For example, this is the death and birth rate. Okay, so it's actually the years multiplied by the groups, which you have Chinese, Malays, and Indians or others, and which is either death or birth. Okay, so it's a natural three-dimensional array. This is a code. We haven't taught file I/O yet, but what happened is this is actually getting in the code last time. So actually not last time. Okay, if you talk about we do the file I/O, we actually have this. But let's say we actually do have a package very easy called CSV. We all know that using Excel, you can save your file as a CSV. Okay, what is a CSV? CSV is actually a text file. That means you actually try to save your Excel file and removing all the formatting. So your file don't have any more the boldface lah, the italic lah, or whatever computation. Okay, you just save it like that. And what you can do is you can use this Python function called open file, open the CSV, and use the CSV package reader to generate a reader. This is not a list, okay? And you convert this list to this data, okay? If you don't understand this, just remember these three lines of code. After that, this will produce a list of data, okay? So if you notice that the last one is this one, right? This one is a two-dimensional array, actually, right? So the two-dimensional array is each one of it is a row, and you have 4 columns or 5 columns, 4 columns, okay? So after that, you actually produce it. You can see that there's a row, and a row, and so on. So you can directly read in with all the Excel file you created. Okay. So if you have some Excel file, some data analysis, you can actually read in, and you can compute all the things you want. Okay. The simple thing you do is I convert it to the array, and what I did is this one I still need to extract what I need, right? Because let's say I want to plot the birth rate, okay, against the years. So I need to extract the years. So for I in birth rate 1, this is row 1. Why I start with row 1? Row index 1, as in the second row. Because your original file have a header, year level 1 values, right? If you go to this file, you can see that the first row is actually the header. I want to skip that. Okay. And what are the years? The years is column 0, right? So I actually extract here. The row is from the second row until the end, and I only want the column 0. That's the I get it from, and I change it to integer. Okay. The slight problem is when you read in, you can see everything is written as a string. For example, even the year 1961, you read it as a string. You have to convert this one into integer I. In the same manner, the number of birth is also, I start from the second row and I took the third column, which is index 2, and this have a list of birth, and this one will be taught in the visualization. Basically, you just need to say plot year number of birth. So it's the plotting the X to the Y. Then you have this Singapore birth rate. Okay, what does it tell you? We need baby bonus. Okay, yeah, but you know why Singapore government is quite serious about this, right? It's not a good thing. Okay, okay, so but anyway, a picture shows a lot of things. Okay, but you can see that since 1960, our birth rate is like dropping like that. As I know, Singapore already a lot of primary school or secondary school need to close or merge or something because of this. Okay, so work hard, guys. You guys are still young. Okay, work hard. Okay, work hard. Okay, so okay, anyway, but no, I just joking. Okay, so some people may not want that, but anyway, that's how we actually collect data and analyze. Okay, so we actually get a graph. Maybe the other thing is after you get this, you do some computation. Let's say I want to find a mean. What's the mean birth rate? I want to find a median, or actually I want to find how to find this peak. You see, somehow in the 1990, you have a peak. Okay, why? Because the baby from here, right? The baby from 1960, when they grow up, is 1990, right? 30 years later. That's why they have babies. Okay, you have a lot of babies in 1960, and after 30 years, they grow up, and there's a lot of baby over there. Okay, and so on. You want to do some analysis and what this and that, and that's how you can use all the data to do. Okay, but that's the next thing is that how do you use this another course like statistics or whatsoever. Okay, so far okay. Yeah, so that's the first part of the lecture is on the multidimensional array, and I would suggest a break because the next one can be some quite mind-blocking. Okay, so there is the real list and tuples computation. Okay, I will talk about how to pass the function into a list or tuples and so on, but I will actually let's have a 5 minutes break and we continue. Okay, that's not easy. Okay, yeah, but in the meanwhile, also if you have any question on the just now the things, please ask. Okay, where did I save the file just now? Yes, here. Sorry. Oh, attendance. I okay. Sorry, let me do all this first because it takes a lot of time to publish. Okay. Yes. Attendance. I think I forgot to take the attendance. I'll let you guys take whatever attendance later. Okay. Maybe Saturday or next. So the attendance, actually, the original motivation for the attendance is your skill future. Some of you use the money, and then I think the government makes sure this one is a real course. Okay, no, it's not that you must come, it's the people must teach. Okay, because I think you know there's some scam. Some people actually create an empty shell course. People just come and use a skill future, but actually the teacher take the money and without anything and so on, right? And I think it's some scam. But anyway, that's the main motivation is that to prevent scam. Okay, but I think for me, I just took the advantage to use as a CA. But anyway, I think I will relax that, okay? Because the whole Wuhan pneumonia thing, like coronavirus, actually make it very wow. I will just let you guys take as many attention as you were when you, even when you just watch the YouTube video, I deem it as you attended. Okay, so I will do that. Okay, I just relax that. Yeah. Okay. Yes. Yeah. Yeah. It's okay. So later on, what I will do is I will just pass around. Okay. So if there's some previous time you didn't sign, just sign it yourself. Okay. Sign your previous time. Okay. Yeah. So just that is done. Okay. Yeah. Okay. One last thing is for those who missed the quizzes, the quiz last week, your makeup quiz is this coming Saturday, 8:15 hours again. Okay. 8:15. Okay. So you go to the room that we have lecture, and then we have the quiz over there. Makeup quiz. For those who missed the quiz last week. Okay. Yes. No, you filter once, right? And you use that to filter again.
So we have the initial filter, then you.
Yeah. It's actually, yeah. So you actually iterate with. So there's no meaning you use the original one.
That's what I was thinking. So let's say if I have, let's say it's 5 times, right? So I have the first original iteration.
Yeah. So you have wave 1.
Then
do
I
one
use
time.
Do one time. Then after that.
Wave 2.
Then after that.
Wave 2 do one time, become wave 3.
So it's always take the one then. So basically, original wave that I plug into the remaining 4 times.
Yeah. So it's actually a very simple algorithm. Yeah. That's why I have the constraint. You must get the previous part right to make it. Actually, just repeat the algorithm 5 times.
Yeah, because the things when I repeat, it doesn't. Yeah, maybe possibly I need to change some parts because I can get the first part right. It's just that I was thinking.
And don't be too serious about the cosmology answer because we are doing numerical computation here. So there's a chance that your number may be different a bit, and then cosmology tell you wrong. Okay. Okay. Sorry. This is an announcement for the assignment, especially for the wave filtering. Don't rely on the cosmology answer to tell you right or wrong. You look at it yourself because it's numerical. All those are numerical answers. So it could be cosmology because your computation is a bit different. So the numbers differ a bit, and cosmology just tell you wrong. Okay. So just by your own visual judgment will be fine already. And we rely on the tutor's marking. But of course, you need to make sure that it's full out. Okay. Yeah. And also, I don't want the cosmology to become your crutches. So you only do think the cosmology is right, and you say right. You have to judge it yourself also. You go to work or whatever you use, no one is going to tell you your answer is right or wrong, right? So you need to judge it yourself also. Okay? So don't treat cosmology as a crutches.
For question 3, right? You mentioned that shouldn't use the input sort of all this.
Right.
But if I use my own
yeah, but there's a bit cheating. You can do that, yeah, there's a bit cheating, but think about how to do it without using that.
I can only think of max and min.
But there's 3 numbers. We cannot use max and min.
Yeah, that's.
Yeah. So that is a good exercise. This is exactly the exercise about. Try to test your logic how to find it free without using. Okay, are you guys ready? Okay, I didn't pause it. So just now at this proposal, we have a lot of rubbish, I think. Okay. Okay. Let's resume. Okay. Any question from the chat? Do we need to inform you that we are watching on Zoom? I assume everybody is watching on Zoom now. Okay. Prof, maybe know information about the Saturday makeup quiz is 8:30
X50 make up quiz is X15 at the room we have lectures on Saturday. Yeah, okay. Yeah.
Yeah, it's the same thing. Yeah, I haven't used that before. No,
the thing is, NUS limited the number of parallel session all around NUS. And what they did is we need to apply for a slot. Yeah, I will try to do that. Yeah, I think I will try to do that next week. I just don't know how that will work and so on. But yeah, I try to. Yeah, yeah. So we are all learning this now also. Yeah. So okay. Okay. Again, we list versus tuples. Okay. It's like two rifles. Why do we want to use list and why do we want to use tuples? And today I give you a more performance-wise reason why do we want to use list or tuples. Okay. Let's revise something about functions. Okay. Remember, we can write a function like that, right? And you have the input. The input is the argument. Okay. I hope by now it's nothing new to you. You have been doing some homework already. Okay. So let's say if I have a square function, what do we have? I actually think that the function is like a machine. Okay. So outside you do have a y. Okay. Y equal to 3, right? And I want you to get get used to this notation. If I say there's actually the variable y, I actually have this y, which is the label. Y is the label and pointing to a box 3. Okay, that's actually the real computer memory allocation. But let's learn this convention or this kind of notation. Okay, so if I say y equal to 3, I write it like that. Y pointing to a box called 3. When I call square 3, what do? I actually copy whatever this, because I call square 3, right? I actually put the 3 values into that. And at this point of time, x is equal to 3. Did you see the x inside pointing to 3? This is exactly like this, okay, over here. But this x is inside the machine, which means inside the function. Outside cannot access to it, okay? And later you return 9, right? Because 3 that enter the function, there is a copy of y, okay? Actually, it should be square y here, okay? I don't know, okay? So, what actually is a bit wrong, it's square y, okay? So a bit of the function, what it does by copy by value is, I call square y here, and I copy whatever y is pointing to the machine. I make a duplicate of that, okay? Outside y will not be changed because I copy this, okay? This under assumption will actually pass by values. However, what is the list? The list, if you think about this situation, right? The list I suggest you to write in this type of notation. The list is called list LSTA, right? List A, right? It's a list of 1, 2, 3. If you write a list notation, the list first point to a square, and the square point to these 3 numbers. Okay, that's the usual convention. We use it for this pointer notation. And when you pass list A into the function, what do you pass? What do you copy? You copy this reference, okay? You copy this to here. So when you go into the function, let's say I call function list A. When you copy list B will point to whatever list A is pointing to. You duplicate that. But what is this square thing? This square thing is the computer representation of pointing to this original, these 3 things. Do you see what is duplicated and what is not duplicated? Okay, you have 2 copies of this list header, okay, to point to the item in your list. But the list item of 1, 2, 3, they're not duplicate. They are the original copy. Okay. For example, I can actually say in the analogy, list A, let's say we have a team of people. Okay, let's say team of people, which is you. Okay. What I did is, if I want to make them into a team, what do? I write a paper. There's 3 names. Okay. So this team is their 3 names. So I have actually a paper writing that. Okay. When I pass it to function, I don't pass this 3 actual person. I copy this paper, make another copy, and pass it to the function. Okay. And in the function, what do they know? They know the name of these 3 people. When they want to do something, they actually can reference to the real person, in which this will only have 3 unique copy of them. I don't duplicate this, I don't clone them. Okay. So that means when you go into the function, this label here is the 3 actual objects, which is 1, 2, 3. What is the implication? The implication means inside, if let's say I got the paper, I say I want to slap the first person. Okay? Let's say the first person changed to 99. Actually, I will reach to the real person and slap him. Sorry, it's not real slap, okay? I actually will affect the real person. Because the paper you pass it into that is only a pointer to the real object. So if I do this, list A, I pass it into the function and I actually access that list and change the first number. What the Python will do is, I actually know that number is the first number of actual position, and I'll change it to 999. I will follow this list because it's a list. The list points to something, okay? And what is the result? The result is the outside list A, when you print list A, you also will become 99923. This is very different from the pass by value. Pass by value is whenever you copy into the function, the outside copy will not change. But for list, this one will change. Okay. So pass by value is the function will not modify the input. That means if outside you have a variable y, you won't modify it. Okay. And so for example, let's say if I want to do this is a list, right? Python has a function called sorted. And this one actually changed the input. I put it, sorry. Yeah, I think I got the wrong example or something. Okay. Yeah, I think I switched the 2 examples. Yeah, I think I switched the 2 examples. Sorry. The 2 examples are switched here. Okay. Actually, the lower one is the pass by value. Okay. For example, this L is equal to the lower one I'm talking about. The lower one, L is 3.14. When I call L dot sort, the original L is not sort. Okay. The original L is sort. Okay. Sorry, actually not wrong. Okay. Sorry, I'm so confused. Okay. Sorry, I'm so confused. Okay. Start again. Okay. Actually, it's correct. Okay. So again. So this one will not modify. For example, this one, L is equal to 34566, right? 345619. L is unsorted. But I pass L into the sort function. The sort function will return me a sorted array. But can you see that is if I call L and print again, is L changed? L is not changed. Okay. So when you pass into a function and the function do not change your input, this one is passed by value. Okay. But otherwise, there's other function will do the same functionality, but actually change yourself. Okay. For example, this one is list. I call L dot sort. You can see that there's no echo. This one actually do not return you any values. But if you print L is sorted by itself. Do you see the difference? One is cell changing, one is not cell changing. Okay. So there is a difference between pass by values, which you keep your integrity of your original data and not. Okay. But let's say if I really want to modify some sequence or produce some new modified sequence, should I use lists or tuples? Okay. For example, I make a very simple function. A function very simple. I got a sequence. I just add one more item 999 at the end. I think by now you should know how to do it. Okay, you can just use a pen or something. Okay, but tuple you cannot use a pen. So how do you do it? Let's see. I just write a function such that I achieve this. Okay, and if I use tuple, right? Let's say if I input tuple is 1, 2, 3, 4, 5, I want to write a function modify tuples to produce a longer tuples, which is just add one item, right? How do I do that? I cannot modify the original tuples. That means I must produce a new copy in which I cannot do this. Okay, the original tuple cannot be modified. So how? The only way to do it is I produce a new longer tuples. And what I do is this. If you see that how this function is, I input a tuples and I return a new tuple, which is the tuple plus that. I cannot modify the original tuple t, but I can produce a new tuples that is t plus 999. Okay, and how I use it is I need to do this. The original tuple is 1, 2, 3, 4, right? I can do tuple equal to modify tuple, in which you take notes. I didn't modify the original tuples. Exactly what is happening here? If I ask you what is x is equal to x plus 1, what is happening? If I write x equal to x plus 1 in integer, so x is an integer, okay? X is an integer. What is happening? You get x, original value maybe let's say 3. You plus 1 become 4, is a new value, right? And you actually replace the original x with 4. You actually didn't modify the original x value to be 4. You actually replace the original x value to be 4. So if you do x is equal to x plus 1, you get the value x plus 1 and replace it the x before. It's exactly happening here. What you do here is the modified tuple function will get your original tuple and produce a new tuples. And when this function return, this world has 2 tuples. One is the original 1, 2, 3, 4, 5. One is the returning values of this, which is 1, 2, 3, 4, 5, 9, 9, 9. And this assignment here will replace the 1, 2, 3, 4, 5 with 1, 2, 3, 4, 5, 9, 9, 9. Gone. Yeah, gone. The old one will be gone. Okay. So you watch those movies that have clone people and the original. Yeah. Okay. And so on. Yes. Very good. Yeah. Later we'll actually talk a bit more on what is the difference between replace. But replace means I totally rewrite the whole. Let's say, I will actually have a very good example later. Okay. Yeah. That's exactly what I try to illustrate that. Okay. Yeah. Let's try to finish it and see how. Okay. So it's actually like this. If you say modify tuples, this one, okay? Let's say if x equal to plus 1, I can actually say x is equal to 4, x equal to modify integer, which return 4, right? And then x become 5. This is called replacing because I didn't get the original any content of that. In which this one, if I return tuple, I return anything crazy, this one actually totally replace. Let's say this one, I just say modify tuple, I just return an empty tuple. Then this tuple will be replaced by empty tuple, right? This is actually totally the overwrite of the original one, okay? Let's see what's the difference when we do list. List is, I want to have a list of 1, 2, 3, 4, 5 and append one item after this. Oops, they'll run out of time again. Too bad for those people who are in the chat room. Sorry that we are going to end soon. Okay, so what happened is watch the webcast later. Okay, sorry about that. Okay, I should have more time and so on. Next time I will do better. Okay. Okay, now I don't need to obey this rule because at least I can modify. So I can actually do both of this. Okay, both of paths by reference or values. This one I can, this one I can. Let's see what is the difference. If I don't need to obey that, I can return a longer list in the modified tuples. It's not the only way. I can do this. Exactly like the tuples. Or, so I can use it like this, right? This is exactly like the tuple, nothing new. Except that I've changed it to a list. Or I have version 2. How about I do this? Right. So I just modify the original one, just add one more, right? Yeah. And I can use a function like this. I don't need to say LST equal to that. If I write LST equal to that, that means whatever result, I will replace the result. Okay, let's go back to that. This one, right? When I do an integer x equal to modify this, it's called replacement. That means I totally rewrite what is x. This tuple is the same. Original tuple is 1, 2, 3, 4, 5, but actually I rewrite 1, 2, 3, 4, 5, 9, 9, 9 all over it. Okay, I produce another new data and overwrite it. But this one, I don't. This one, version 2, I actually, there's no another list is created. All the way in the whole memory, all the time only have one list. It's not destroyed, not deleted, not disappeared. It's all the way there. Yes. Right. Yes and no. List is very complicated. List can be not what you think. Yeah. List is not copying. Okay. Okay. Yeah. Okay. Yes. Next two slide. Very good question. That means you are following. Good. Yes. Right. Yeah. 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 Totally new 1, 2, 3. Yeah. Oh, if you do override, is like this diagram, right? You actually create another 1, 2, 3. You make a duplication of the tuple 1, 2, 3. So this one also can do the tuples, okay? But this is not the one. This one can do the tuples, and you actually make another 1, 2, 3, 9, 9, 9, and you override this, okay? Let's see if I can illustrate with my final example and also answer all those questions, okay? Yeah, okay. So okay, so this one is a pen, okay? Let's leave it hanging there and let's see if my illustration make it more clear, okay? First of all, this is a list. This one will return the value to copy to LST, okay? But this one, remember, is also copying the square. So this one also actually didn't create a copy because list is just the pointer. This one modified the original list, okay? And what is the difference between those three versions, okay? And exactly, I hope this answer your application question, okay? Let's try this. I want to repeat this process 100,000 times. So I want to add this to tuples or whatever, add this 999 100,000 times. Okay? And these are the function I do. Now you should, the thing you don't know is this time, right? This time actually will give you a time that is in seconds, okay? In seconds, in floating point seconds, the current time. So you can see how I time it is. When I do this that time, and then I run this, and that is the original is the new time. I do it again because each time you call it, we get the current time and minus the original time. Then you actually get the time lapse, right? That's how it's like stopwatch. Stopwatch is easy because you start with 0. But if I want to measure something's happening, okay, I actually measure. Oh, now we are actually starting lecture at 7:50. So I record the time here, 7:50. And after the lecture, I actually is the current time. Let's say it's 8:10 minus 7:50. Then you got the time, right? Not me, right? Somebody's yeah. Okay, you know what's going on? So there's a time that anyway, if you don't understand this is a method of recording how much time you do it in this loop. The loop is just repeating 100,000 times on how do I do that and see what is the difference, okay? So this time is actually is the time starting from the April time, which is 1970, 1st January times 00. You can actually get a floating point at large numbers. And the number of seconds after that. So you actually, if you get the difference of time, then you actually get the amount of time you spend in something, okay? And the result is like this. Okay, do you see the difference? Tuple takes a lot more time. But it's not only about that. The tuples, if you, let's say I want to run double, the time increase is not double. It's 4 times. This will go to our next course of IT5003 to tell you why, okay? But here I show you a glimpse of it, why, okay? Why is this so much time? You see, it's the ratio is, wow, is 1,000 times, okay? Why is it so slow? Okay, why? But why do we want that? Because it's exactly when you go out to do programming, whatever, you actually need to take care of this. It's actually, I always tell students, this is actually the heart of computer science. How is not only you can do something, how do you do something quick? Okay, you see the functionality is the same. I just add numbers, but how come some very slow, some very big? Okay, why is the tuple very slow? I tell you a story when I was young. When I was young, I was quite naughty. Okay, and what happened is the punishment when I was young is when I'm noisy in class, it's asked me to copy. So when I was noisy, the teacher will ask me to copy the Chinese word quiet. Zheng is the word in Chinese. Zheng. It's like copy. Okay. So if I make noise in my class, my teacher will tell me to copy. Usually it's like 50 times, 100 times. Okay. One time I submit my copy of the word 50 times. Okay. And somehow the teacher said, "Hey, it's 100 times I told you." Okay. What should I do? I copied 50 times already. Should I go and copy another 100 times? Or what is the more clever way? I'll copy 50 more to add it on my 50 times, right? That is exactly difference, okay? So the difference is, if the evil teachers, after I submit 100 times, she told me, actually it's not your 1 day late, it's 150 times. And I go back and come back, is the teacher saying your 2 day late is now 200 times. What if I keep doing that? What is the difference between I totally copy the times you need from scratch or each time I add in? Okay, let's try. If you use the tuple method, each time when you have a new tuples, it's like the first dumb method of my copying. If you have the list of 1, 2, 3, 4, 5, 9, 9, 9, you actually have to copy the whole memory to the new variables. And the next time you put it into the again, and then you copy 1, 2, 3, 4, 5, 9, 9, 9, 9, 9, 9. And you do it to 10,000 times. The first time you do copy 8 numbers, right? And the next time is 9 numbers. And next time until the last time is like 100,005 numbers. And you have to add all the times. Okay? They come with like super long time. Okay? You are adding 1 to this number. So probably it's a few millions, okay? Not a few trillion number, okay?